Today we're going to discuss a typical problem related to fractions. In some way, this is a classical problem. So one type of this problem looks like the following. Monty the monkey had a pile of apples. On the first day, he ate 1/2 of all apples. On the second day, he ate 1/3 of the remaining apples. We need to pay attention. This is actually saying the remaining apples. This 1/3 is not the original 1/3 of the original pile, but 1/3 of the remaining apples. On the third day, he ate 1/4 of the remaining apples. And on the fourth day, after eating 1/5 of the remaining apples, again, pay attention, this remaining now is after the third 3 days. That's the remaining apples. He ate 1/5. He found there were still 24 apples left. Question: what was the original number of apples? So first thing we noticed that this Monty the monkey was very disciplined. So first day he ate 1/2, but then the second day he realized probably the apple gets smaller, so he said that maybe to himself, I need to eat a little bit less. So 1/3. And the third day he ate 1/4. And on the fourth day, he ate 1/5. And then he realized still, there are actually quite plenty left, 24 apples. Question: what was the original number of apples? So one way to solve this problem is through a backward derivation. What do I mean by that? First, let's try to draw a graph model to really understand the problem. Okay? So he starts with a bunch of apples, some apples. Let's put some apples here. And we don't know how many. On the first day, he ate 1/2. And then there will be a new number remaining. It'll be definitely smaller than the first one. And then on the second day, he ate 1/3 of this remaining number. And then on the third day, he ate 1/4. And on the fourth day, he ate 1/5. And then what remained was 24 apples. So the way to do it in backward fashion is you do from the back. So start thinking about on the fourth day. We ask how many apples left at the end of third day, but the beginning of fourth day. So we know this, after ate 1/5 of this number, we're left with 24. So that means 24 is corresponding to 4/5 of this unknown number, right? So this unknown number is going to be equal 24 divided by 4/5. Now, how we do division of a fraction? We change to multiplication of a fraction. This equals 24 times 5/4. By swapping the numerator and denominator of this fraction, we can change a division of a fraction into a multiplication of a fraction. A different way of saying it is by using algebra. Just let's say if this number is a x, so then x times 4/5, because eating 1/5 left with 4/5 equals 24. So x equals 24 divided by 4/5, which equals 30. All right, so we know that this number is 30. Now we ask a similar question. What was the number to begin the third day? Or what was the remaining number after the second day? This x times 3/4, because on the third day, Monty ate 1/4, so left was 3/4. equals 30. So this new x, I should rather using a new x. Let's using x prime. So to differentiate between this number and the number that the remaining after third day. So let's x prime times 3/4 equals 30. So x prime equals 40. Okay, so we got the number. What was left after second day? Let's go backward one more step. You see, and we're getting closer. If we get this and we do one more step, we get the original number. So really by doing the same thing, let's call this number x prime prime, a new number different from x prime. So x prime prime times 2/3 equals this x prime, which is, we already just calculated, this equals 40, right? So this equals 40. So x prime prime equals 40 divided by 2/3 equals 40 times 3/2, because division equals a multiplication by swapping the numerator and denominator, which has a terminology called the reciprocal of this number. This equals 60. Okay, we're getting really close. So this number equals 60. So now we really can calculate very easily. On the first day, he ate 1/2 and left with 60. So we know the original number is 120. Let's put this a little bit more formally. Let's assume this is y. We want to calculate y. Y times 1/2 equals 60. So y equals 120. So this way is working backward. We first start with 24 and we calculate what's the number remain after the third day, or what it was the number of apples at the beginning of the fourth day. So with 24 we get 30, and then 30 to get 40, 40 and to get 60, and 60 finally we get the original number of apples he started with. Now it turned out the second solution, we're actually going to just work in a forward fashion. It turns out to be as simple as working backward. And I like this approach because it gives you a very logical way of thinking. So let's assume that we start with the number y. The original number is y. So what was going to be the number of apples after the first day? The number will be, see, if I start with y, this number is basically the number of apples after eating 1/2 of y. So it's going to be left with after first day. What remains is going to be y times 1 minus 1/2. Because 8 1/2, so left with 1 minus 1/2. Of course, we know this is just equals y times 1/2, because 1 minus 1/2 equals 1/2. So this is the number that here. Okay, this number will be y times 1/2. Now, this is the exactly number that start with on the second day. And Monty ate 1/3 of y times 1/2. So now, what is going to be the number that after the second day? After second day, the number will be this number times what was the number beginning with on the second day times 1 minus 1/3, because he ate 1/3, so what's remaining is 1 minus 1/3. So this whole number equals y times 1/2 times 2/3. We have this number, y times 1/2 times 2/3. How about this number now? this, now you see the pattern. This number will be y times 1/2 times 2/3, which was the number to start with here. And then after 8 1/4, what's remaining is times 1 minus 1/4. 1/4 is what I ate, eaten, and 1 minus 1/4 was left. So this equals y times 1/2 times 2/3 times 3/4. Finally, this number, if we start with this number, this remains after eating 1/5 is going to be y times 1/2 times 2/3 times 3/4 times 1 minus 1/5 is going to equal 24. That's the problem tell you. There were still 24 apples left after eating 1/5. So this is going to be y times 1/2 times 2/3 times 3/4 times 4/5 equal 24. Now you want to solve the y. Interestingly, you see a very cool pattern here. 1/2 times 2/3 times 3/4 times 4/5. You see, for the consecutive terms, the denominator of the former, the first term, is actually the numerator of the second term. So they cancel each other. This with cancelled with this, 3 cancels with this 3, 4 cancels with this 4. So left with is just y times 1/5 equals 24. So y equals 120. And that's the second way of solving by doing forward thinking. So we basically talk about two solutions. One is working backward, which is also a very nice way. This makes your thinking much clearer. Every step you only from what's left to get what's begin with. Or you can think just forwardly, in a forward fashion. Just list the whole equation and solving the y by doing just one step in the end.